Good morning, students. Now come again to chapter 15 Properties of Triangles. Today we have a very interesting topic Pythagoras Theorem.
Pythagoras theorem. So Pythagoras theorem is only for right triangles. So what is a right triangle? Right triangle is a triangle in which one angle is of 90 degree. So we can see this triangle ABC is a right triangle and it is right angled at B. So this is a right triangle and this is called the base of the right triangle, and the side which is making 90-degree angle with the base is called the perpendicular. So this is the AB is the perpendicular of this triangle ABC. BC is the base of this triangle ABC, and the side which is opposite to the right angle, this side is opposite, this AC side is just opposite to the angle B. So this side is called hypotenuse of the triangle. This is the longest side of the triangle, means this AC is the longest, means it is longer than AB and as well as longer than BC. So Pythagoras theorem says that in a right triangle the square of the hypotenuse equals to the sum of the square of its remaining two sides. So it is, I forgot to write ing here, you will write by yourself, and it means the hypotenuse square means this side AC is the hypotenuse. Hypotenuse square is equal to the sum of square of its remaining two sides. So which are the remaining two sides other than hypotenuse? Base and perpendicular. These are the two sides which are remaining. So the sum of square of these two means base square plus perpendicular square. So Pythagoras theorem says that the hypotenuse square is equal to the base square plus perpendicular square, and this is only for right triangles. So we can see here ABC is a right triangle at B, and the hypotenuse is AC here, so hypotenuse square. Now we have a small experiment. Three triangles are already drawn here. Their names are T1, T2 and T3. So we need to label each one of them as triangle ABC. The name of all the triangles is ABC. Triangle ABC, this one, and this one is also ABC, and this one is also ABC. And their sides are small ABC. We can see ABC here also ABC. So in all three, the sides are ABC, small ABC, and these all in these all three triangles, these are right angled at angle C. We can see at C angle these are of 90 degree. So in each case, measure the sides ABC. We need to measure the sides ABC. C is the hypotenuse in all three triangles. So we will measure these all. That this table is given to you. You will write the values of ABC and A square, B square, and C square, and also you will find the a square plus b square, means you will find the sum of a square and b square here. For this first line is for T1, means for the first triangle only. The second line is for T2, means second triangle, and then the third line will be you will write for the third triangle, and then after you will also find the what c square minus, in bracket you will write the sum of a square plus b square. So you will find, means in each case, means for all three triangles this value will be 0. Let's see with one example. For example, the one side of triangle is 3 centimeter, second is 4 centimeter, and third is 5 centimeter. So a square means 3 square, it will be 9 centimeter square, and b square means 4 square, it will be 16. 4 square will be 16. Then a square plus b square means 16 plus 9 will be 25. And c square means 5 square, it will be 25. Now we need to find c square minus sum of a square plus b square, sum of a square and b square. So c square we have 25, for c square we have 25, then minus a square plus b square, means we'll write this sum, this also 25, so answer will be equal to 0. So in each case this value will be equal to 0. So you will do this. And one more thing, we have observed that we got a square plus b square, it is also 25, and c square is also 25, means hypotenuse, C is hypotenuse here, so C square. Now the next topic is Pythagorean triplet. A, B, C are three positive integers. These are called Pythagorean triplet if C square is equal to A square plus B square. Then we can say that A, B, C is a Pythagorean triplet. C will be the largest one because C square is equal to A square plus B square. So if three integers, positive integers are given, and the biggest one square is equal to the sum of square of remaining two integers, then we can say the three. For example, we have 3, 4 and 5, and we can see 5 is the greatest one among these. So square of 5 is 25, we can see here, and the remaining two integers are 3 and 4. So first we'll find their square and then we find the sum of these two. So 3 square will be 9 and 4 square will be 16. The sum of 9 and 16 is also 25. So we observed that the square of 5 is equal to the sum of square of. Now come to the exercise 15D. The first question says that find the length of the hypotenuse of a right triangle, the other two sides of which measure is given how much? 9 centimeter and 12 centimeter. So this is a triangle ABC where one side is 9 centimeter, other side is 12 centimeter, and we need to mean base and perpendicular are given, and we need to find the hypotenuse only. AC is the hypotenuse. So by Pythagoras theorem, we have hypotenuse square is equal to base square plus perpendicular square. So hypotenuse is AC here we can see, and base is BC, and perpendicular is AB. So in place of hypotenuse we have written AC, in place of base we have written BC, and in place of perpendicular we have written AB. So we don't know the value of AC, so we are writing as it is AC, and in place of BC we are writing the measure 9, so we'll write here 9 square. In place of AB we are writing 12. AB square means 12 square. Now in the next step we'll find the square of 9, it will be 81. Square of 12 will be 144. Now in the next we'll add these, it will be 225. So to find the value of AC, we have to remove this square from AC. So when we'll remove this square, so it will come there on the right hand side, and it will come as square root in this form of square root. So to find this square root of 225, we'll find the prime factorization of 225. In the rough part we'll find the prime factorization of 225. So we can find by the table of 5. 5 4 times is 20, 2 remainders, 5 5 times will be 25. Now 5 9 times, and 3 3 times, and then 3 1 time. So we have two 3's and two 5's. So I have not written this step, I'm writing here. Inside this square root you can write here 3 into 3 into 5 into 5. There will be 2 3 and 2 5's. Then we will make the pairs. So there will be one pair of 3 and one pair of 5. I'm unable to write here properly. We'll write in your notebook. We'll write the one pair of 3 and one pair of 5. So these pair can come out from this square root because we have got the pair. So if we make pair of any number inside the square root, that pair can come out from that square root, and it will come as single, not in the pair. When it will come out, it will come as single. So one pair of 3. So now come to the question number 3. The question number 3 says that the length of one side of a right triangle is 4.5 centimeter and the length of its hypotenuse is 7.5 centimeter. Find the length of its third side. So here we have the length of hypotenuse and the one side. We know the measure of one side, length of one side. So in triangle ABC, by Pythagoras theorem, we will use this theorem here. First we'll write the theorem. It is h square is equal to hypotenuse square is equal to base square plus perpendicular square. So here we have hypotenuse, so we'll first we'll write here AC is the hypotenuse, so write AC. Base is BC, so we are writing BC in place of base. In place of perpendicular we'll write AB. Then after we'll put the values. Hypotenuse is given 7.5 centimeter, and we have given what? Base is given how much? It is for one side is given, so we can take this one side as base or perpendicular anything, I have taken it as base. So in place of base we are writing 4.5, and in place of AB we are writing as it is because we don't know the value of AB. So now to get the value of AB, first we will transpose the next term from the right hand side. On the right hand side we have AB. So to find the value of AB, first we will transpose the other terms. So AB square is other term and this is another term. So we will transpose this 4.5 square towards the left side. So when it will go towards, it will become negative. So we have 7.5 square minus 4.5 square. So we have two ways here. First, that we can find the square of 7.5 and 4.5. It will be little bit typical for us, and we have another way that will be easy. We can use the identity a square minus b square. The identity a square minus b square is equal to, we already have done in the previous classes, a square minus b square is equal to a plus b into a minus b. This identity we are going to use here. It will be easy for us to solve. So we have in place of a we have 7.5, in place of b we have 4.5. So a plus b means 7.5 plus 4.5, and a minus b means 7.5 minus 4.5. So now we'll solve. So 7.5 plus 4.5 will be 12, and 7.5 minus 4.5 will be 3. So 12 into 3 will be equal to 30. The same thing is written here, that AB is equal to square root 36. So now we will find the prime factorization of 36 at the right side in the rough part, and we know that it will be, we know it is 6 into 6 is 36. So I am writing here directly on the side the square root. Otherwise you can write 2 into 2 into 3 into 3 in this way. So we have a pair of 6 here. So from this pair 1 6 can come out, means this pair will come out. Now see the question number 4, that two legs of a right triangle are equal to the square of its hypotenuse is 50. Find the length of each leg. So first of all we should know what are legs here. So in a right triangle, other than hypotenuse, the remaining two sides are called legs of the right triangle, means base and perpendicular. So here in this question, the two legs of right triangle are equal, means base and perpendicular are equal, and the square of its hypotenuse is not given, its square is given, it is 50. So 50 unit. So we need to find the length of each leg, means we need to find the length of base and perpendicular. So here we have a square of hypotenuse, it is 50. You will write here unit. We don't know, unit is not given, centimeter, meter, anything can be. And the length of other two legs b, we are assuming the length of other two legs, it is given that both are of equal length. So we are assuming the length of the other two legs b is x centimeter, and x centimeter or unit we can write. So by Pythagoras theorem, first we'll write the Pythagoras theorem, then we'll put the values. So hypotenuse square is given already. 50 is a square of hypotenuse, it is given in the question, is square of hypotenuse. So we are writing here 50, and base square plus perpendicular squares, we have assumed base and perpendicular as x. So x square plus x square, so it will be 2x square. Now we will move this 2 towards left hand side, it will come as divisor. So 50 divided by 2, it will be 25 we have now. Now we will remove this square from x, and it will come as square root 25 on the left hand side. So square root 25, we know that 25 is a square of 5, means 5 into 5 is 25. So we will write, and we have a pair of 5, so this pair can come out from this square root, and it will come as single.
Now the question number 7, the length of the sides of some triangle are given below. Which of them are right angled? So we need here the length of three sides of triangles are given. So we need to find whether these are right angled triangle or not. So we'll take the Pythagoras theorem. Which is the longest one? C is the longest one, longest side. In each case, C is the longest one. So we'll write this, and then we will find if LHS RHS equal, means we are writing place of C, we are writing 25 square, A square means 15 square, B square is 20 square. This is the Pythagoras theorem, right? So 25 square is 625, 15 square will be 225, and 20 square will be 400.